All right, guys. Welcome back to Fan Addicts. Sorry, I've been a little on and off with you guys since the beginning of the year, but we're getting our act together. And as we noted at the end of last year, old Eden has moved on, and we got Drew coming along and helping me out here. But we're going to get a. There should have been a video posted before this one goes up, but you'll see him on there. And we figured we'd squeeze this one in just to try and stay a little bit more regular and get you guys up and running. So we always used to start out the week with, "What'd you do this weekend?" Nothing too crazy. Couple cruises. Truck's a little dirty right now, so cleaned her up. But did the Grand National show last week, and I got my honorary participation award because I always get third place. But hey, third's better than fourth. So anyway, off to a good week. Nothing too crazy going on. If you guys are interested on the CT Fan Man side of things, I'm starting to tear into the Dotson I think I made mention of. So there's going to be some action going on over there. It's getting hopefully sandblasted in another week and getting on with itself to the metal guy and get all straightened out so we can get her looking pretty. Change it up a little bit. So, this week I wanted to kind of circle back to simulations and, how we can do that for you guys. And I'm going to be kind of looking here on my computer at a few things, but we'll have the magic video post up some of these pictures of things we're doing, right? So, there's all kinds of great value added that we can do for you guys. And I really feel like that's one of our number one strengths is getting in, taking a standard product. So you're not going to have to spend a bunch of money on tooling, but then dialing it in for you so it's perfect, right? Whether you're medical or industrial or, whatever industry you're in, right? We've got a few of them that we feel like we're really good at. We can do the upgrades that you need. And, I just want to kind of hit on a couple of those today. Maybe it'll strike a chord with you guys, so I thought I'd give you an example of a customer recently that came to us and, they're like, "Man, we're kind of having these little issues on our production line." I'm like, "Wow, what's going on?" And I said, "Well, it's we know that you mark your fans with an airflow direction, right? Like if you take our fan, actually I can put a little picture up here. We can zoom in on the side. It shows the rotation of the fan in the direction of the airflow. And just for the record, like when you look at a fan and you're reading my label, right? YS Tech, got the part number there. It's going to be blowing you in the face, right? That's exhaust over struts. That's 90% of fans are that way. Now, if you do reverse flow, there's a lot of reasons for that. Maybe we'll address that someday, but not today. So, our customer comes to us and says, everything's going good. Fans are good. We don't have any issues. Well, we don't have any quality issues, but we got an assembly issue. So, well, what do you mean? He says, some of our people, they don't recognize the direction of the airflow. They put the fan in the unit. When we go to test it, we realize it's blowing the wrong direction. I'm like, okay, all right. So, that's a little bit of a difficulty, right? So, we'll put some pictures up here and you can check this out. So what we were trying to do, we said, well, hey, let's look at this and how can we make this part to where it could never get put in? The Japanese call that applying poka-yoke to a process so that it's the same every single time. So, we kind of looked at some of the things we have going on, some of the history of how we've helped customers do that. It's a very common feature in the automotive world. And, you can either put a notch in the frame, you can plug one of the mounting holes, there's all kinds of things you can do. So we said, you know what? Like check out in this picture right here in the fan, you see that little green vibration isolator that's in there. What we did is we put it in backwards so that it's not going through sheet metal. It's just plugging that hole. So we're talking like a 5-cent part that we can just stick in there. No tooling cost, no process changes. And what that does is it makes the fan only mount in their system one way. Because if you turn it any other way, you can't put a screw through that hole. So, we were able to come in, no redesign, no qualification. They got it. It added a nickel to their price, but it saved them a ton of time because in production, if you've got a part that's already all buttoned up and then you realize when you're testing it, the fan's blowing backwards, then you got to send the product back for rework and it costs you a whole bunch of money, right? So that's kind of a very simple thing that we have done for a customer to be able to add value in the production process, not even just in the fan process, right? And the other thing that's in this picture, we'll bring it back up one more time, was this thing's got a Tyco connector on it. There were some issues with broken latches, and we're not going to get into the who, why, or what of that. But the bottom line is we had broken latches, like the little, safety latch that goes on there so it won't come unplugged. Um, we'll just say Tyco wasn't very cooperative in the process, so we felt it like it was our responsibility to make these things right. So, what we did was you can see in the picture up here that in our packaging, instead of the fans being right next to each other, row to row, we were able to put about a 5 to 7 millimeter space in between the rows and the cardboard. So, when we put the fans in there, because we're doing the connectors and labels and all that stuff for them, we could actually put the wire into that cavity or void in the slots in between the rows. So there's no possibility for the connector to get smashed, which we don't think was the problem. But in the end, it's all worked out. So we got them an upgrade on the poka-yoke for production. We got a packaging adjustment that didn't cost anything, and we were able to tune that up. So pretty sweet little fix up there. Now I'm going to bring up one here that is a little bit more sophisticated, right? So I just call this a deep dive case study. And of course, if you guys are interested, you could always give me a call or give me a call about your device, and I'd be happy to dig into it with you. But this one here, we'll bring it up on the screen. You can see the customer actually shared their device with us. And the goal here was to take a production item that's already in volume production and see if we couldn't reduce the noise, right? And do something a little bit different. So in this case, we were going up against our good competitor, Sanya Dinky. And, we're showing here, we take their device, we do the acoustic test with the competitor's part in it, we do the test with our part in it. We can give you a really nice frequency spectrum report, because just measuring dB is not going to give you a true read, right? You need to know where the frequency bands are and where the spikes are so that we can identify, what we're hearing and where the problem areas are. So in this case, we were able to be better at a lower RPM, and then the temperature comparison that's below that on the chart up here. Sorry, I keep looking at my screen and this screen and that screen, and we'll let Mr. Editor get it all right for us. But the second one is showing how our part is actually giving them better cooling too. So if you look at the numbers that are on the right side of each one of those graphs, you'll see in having better noise and better cooling, our part's doing the job better all the way around. So in this case, there was like a 40x20 in there. We were offering a 50x15 that we felt would do a way better job in this specific application. So, you're like, okay, Charlie, that's all fine and dandy. Well, the whole point here is we did this and the customer didn't have to do it. So it saved them that week of work to do the setup and the test and put the data together and all that, right? They just gave me the device. We identified what the goals were. We processed it in Taiwan. I think it took us a week or two once we had the time scheduled in, and there you go, right? You get all the facts. All the tests were done in the same equipment. Some people might say, well, you're testing somebody else's fan and this and that. Well, it's an even playing field, right? Both tests are conducted in the same acoustic chamber with the same parameters. So we do feel that it's very fair. We're very honest about that stuff. So this was a noise and temperature comparison. I've got another one here even. This one is an airflow and noise thing here. So we'll pull this one up. This was a power supply that has, let's see here how many it's got. It's got 6 heat sinks in there and 4 fans. So we're looking at the heat sinks because what the circumstances here is that this was an older design, right? And they got a new design. They need more power, more wattage to drive their device. And so the heat sinks are all overheating. They're not sustaining the ambient temperature they need. So they come to us and they're like, hey, Charlie, this is a tooled box. We got all this going on. We don't have room to grow the space at all. So what we did, this middle picture here, we'll bring it up. You can see the 2 heat sinks. The one on the left there is an extrusion. The one on the right is a zipper fin, right? So the whole point of this is we were coming in, showing them what our extrusion would do, which they kind of already knew. And then we put the zipper fin in there. So we run the simulation. You can see below where the green one is definitely showing how hot the heat sinks get. The blue one is showing what happens when we introduce all the airflow. And then the spreadsheet at the bottom there, you look at it's called the soldered heat sinks. Look at the temperature difference between the two. You go 5 to 10 degrees better just with changing the heat sink technology out, right? So that's what we got going on over here. You know, we can come in, we can look at designs, we figure out how to optimize them, we can do all the data for you, and you don't even have to lift a thumb to do all that other than a couple of clicks to send me some files to get into this, right? So how much easier could it be? So that's what I want to do for you. But all right. Well, I think we're going to keep it short and sweet this week. So, you know, that's kind of the quick rundown on simulations if you or other optimizations of parts. So, if you've got any problems and you want some help, reach out to us. I'm happy to help. You know, we'll put all of our credentials and things up there, but I'm Charlie at ystechusa.com. You can get me anytime, anywhere. So, I hope we can maybe get some stuff to work on here in the near future. But all right. Well, we're in a rush today. We're getting it done. That's that. Stay cool. Later.